So we're in South Carolina today. Brent Jeffries with Bierer Meters. We've got Mr. Ryan.
Come over here. Ryan Bierer.
Okay, he's my nephew. He doesn't like to talk a lot, but he's my nephew. And behind the camera,
Parker Hyde.
field representative, right? Parker Height. I'm VP of Field Operations for Bierer Meters, and what we do is, most of you already know, is we manufacture testing equipment for linemen, voltage indicators, phasing tools. We have grounds tester, cable ID. We got all kinds of tools for about 35 years now. Walter Bierer, my stepdad, he's the owner of the company, and our live line, why don't you pan real quick, Parker, show them our live line training center. Here in South Carolina, the sun's coming up. We got cakes on the griddle. And there's our live line training center. We're gonna be doing this training today. It's gonna be called Lineman Safety and Tool Training. We're gonna come off of this trailer here. We got 3-phase, 19.9, 34.5. And what we do is, for the last 4 years, we've been doing this lineman safety and tool training across the United States, coast to coast, border to border, for about 4 years. And we do this at no cost. It's us giving back to linemen. We give back. So our sales are good, we do fine. And so this is just us giving back to the industry, help folks out with some safety and tool training. We're gonna give you guys this safety and tool training from a perspective of a manufacturer. And we're going to go over some things that you all may not have ever heard before from this perspective, but they're things that are super important, and incidences across the United States do happen because of a lack of the training that we're going to do today. And this training, I believe, and many folks have told me face to face, that this should be mandatory. So hopefully you guys can help us spread this out there and share it with folks. What we're doing is we're starting basically a coalition of safety in the industry, to where we talk about these incidences. We don't mention names, we don't mention utilities or contractors or anything of the sorts, but we want to have free access to incidents and the ability to discuss them with one another so that they can be prevented, so other folks return home and they can see their families and take care of them. That's important. So we're starting this coalition, and we'll actually have a national webinar, Lineman Safety National Webinar, February the 17th. Danny Rains will be our visiting guest. He's going to talk about electric system grounding. All right, so it should be pretty cool, and pretty good for everybody to come on in on the 17th of February at 9 a.m. Eastern Standard Time. And all these webinars are recorded, so if you cannot participate, cannot make this part of your safety meeting, then you're able to ask for a recording and you keep it for your safety archives from that day forward. All right, so this will be an open forum. You all are able to ask questions if you have any questions, and I'll stop from time to time. So if you have a question, maybe write it down, take a jot, and then you can ask it if it wasn't answered prior to us getting to you. So these are always open forum. Well, good, Parker? Okay. So the first thing we're going to talk about is the grounds tester. This is Walter Bierer's first tool he came up with about 35 years ago, got him on the map, and it's real easy to use. On your TPGs, if you go to OSHA 1910.269, if you go to N, lowercase n, I know you guys can't see it, lowercase n, it talks about grounding and protecting, setting up your EPZ to protect your employees. So the responsibility is that the employer is going to make sure that the TPGs are inspected, they're in good shape, they're electrically tested, and that goes to number 4. Lowercase I. If you go to lowercase I, it talks about how the guidelines are the ASTM F855 and the IEEE 1048. Those are guidelines. Real small print. I think it should be a little larger print, but it's there. So if you go to the guidelines, it talks about visually inspecting, it talks about mechanical inspecting, it talks about electrical inspecting. It doesn't say how often you're to electrically inspect, but we recommend once every year, once every 12 months or so. And when we complete a visual inspection prior to use. So this is going to be a regular thing that we're going to do. It's going to take a little extra time. Linemen are getting paid by the hour, so that's okay. Take a little extra time and train them to visually inspect their temporary protective grounds prior to use. So we're looking for a lack of pinched copper. We don't want to see any smashed copper. We don't want to see any blackened copper or patinaed copper. We want to make sure everything looks good. There's no oxidization on our components. We don't want to see any cracks on our clamps. And just make sure everything looks pretty snug. We also don't want to see any bubble jacket. Then we're going to go ahead and do a mechanical inspection. And we're going to literally grab a hold of the assembly and make sure we cannot twist the clamp off the ferrule. And make sure the cable is nice and tight in the crimps of the ferrule. Been to a lot of utilities around the country, and that we're not training their linemen to visually and mechanically inspect their TPGs at all, basically ever. And that's pretty freaky to me. These are to be considered a best friend, so you always want to take care of your best friend. So we're going to do an inspection prior to use. So we don't want to see any broken strands neither on our TPGs. And I've been to a lot of utilities where everything we don't want to see, we actually see. And the reason why we see is because they were not inspecting and they were not testing their TPGs, which is incredible. But the good news is after our visit, work methods and safety and all that changes rapidly. And so now thousands of linemen today, because of our visits over the last 4 years, thousands literally, are much safer than they were prior to our visit. So it makes us feel good, all right? So we're going to continue doing this until everybody gets this. And until then, we're going to keep doing it, all right? So on your electrical inspection, we're going to make sure that you inspect from clamp to clamp, point A to point B, just like we have here. You don't want to take your clamps off and electrically test from ferrule to ferrule like we've had discussions with a few utilities, and they made those changes, so that's good. But we want to electrically test the entire assembly. And in doing so, we want to make sure that we have the cable in parallel, similar to this. Maybe have a 2x12 with some 2x4 on the sides. Have it pre-measured so you know how long your cable is without getting the tape measure out. Just slap it in there and do your test. We have it in parallel. The reason why is because you do not want to create a magnetic field. When the cable is in a circular fashion, such as this, what happens is the tests, one, are not consistent. Say between a 5-foot ground and a 20-foot ground. Because your circle is small, then your circle could be large, so your tests are inconsistent. Plus, you're creating that magnetic field, and you don't want to test the cables in a circular fashion whatsoever, such as this right here. All right? Because that creates a magnetic field as well. Ryan, you want to show them? That bottle back there. We're going to take this Variac and we're going to put 300 amps on this number 2 cable. All right, and you can see that magnet getting kind of crazy there. Brady Hansen, one of the safety trainers that we confide with, he has a great YouTube video, and you can see that YouTube video that he does. It's pretty amazing. So it creates a magnetic field. Ryan, you want to show them parallel? And you see that there's a lot less activity now with that magnet, a lot less. All right, so we need to keep this in mind because of that proof right there that we just demonstrated. When the TPGs are in use, if there's extra cable, you don't want to have your linemen coil these up and run some tape around the coil. If the TPGs got hit with a potential fault current, what happens is that cable wants to escape from itself, and it could start whipping around, and it could cause an injury. So you want to use your TPGs basically in as straight as line as possible. Some droopage is fine. That's fine. But they're going from point A to point B, your conductor, point point A conductor to point B as much a straight line as possible. No coils, no circular fashions, no leftover TPG in the bucket truck or laying on the ground or anything like that. You don't want them coiled, all right? If you have extra, then maybe you need another assembly put on the truck that's a little shorter than the longer one, okay? So what we're gonna do here, a number 2 cable requires 165 amps. So we're gonna simply put 165 amps on the number 2 cable. Bring it down a little. Get some parallel. And you can see that voltage drop meter at the top is running a little on the high side. So our chart says that we need a 0.26 or less of a voltage drop. So this is running a little high, so it does not pass. So what we need to do is get a heat gun, and we want to make sure a fluor camera or a pyrometer and see the hot spot. And that hot spot is where the resistance is. So we want to make that repair, whether it's changing out a ferrule, cutting back 6 inches, put a new ferrule on, and then re-crimping or cleaning the components or even tightening the components. We found just the components being loose because they weren't mechanically inspected. Then that fixes it. It's real easy to find and real easy to fix. Also, you'll notice that these contact points are not brushed. So we have some heat, we have some resistance at those contact points. So the lineman needs to make sure that his contact points on the clamp and the conductor are clean prior to installation. All right, so that's a good test. Okay, Ryan, you ready?
Yeah.
Okay.
So now we'll go ahead and start talking about some metering tool, basics, functionality, performing a battery test, things as such. For any manufacturer's tools, doesn't matter whose testing equipment you'll use, again, voltage detectors, phasing tools, voltage indicators, doesn't matter. It's important to know a battery test is just a battery test. It's not a true tool test. For anybody's tools, all you're using is the power supply, whatever that may be inside the tool, to give a partial test of the battery itself and a couple functions of the tool. But if you think about it, it's not what you would call a true tool test. There's no transformer inside anybody's tools that steps that power supply up, ours being a 9-volt battery, up to high voltage, what you would call a true tool test. So keep that in mind. We hear a lot about folks teaching that a battery test is what you would consider a true tool test. Brent will go into more depth on what you would call a true tool test here shortly. But real quick, I'll just give you an example of what to expect. For a horn and light, an audible visual meter, you want to either flip to the test position. Some manufacturers have a push button. You want to flip to that position. You want to hear the horn and see the light. If you don't hear the horn and see the light, get both indications. You want to swap the battery out in the tool for a good known working battery and retest. All of our tools have live line tool fittings on the front. You just unscrew that. Again, pull the 9-volt battery out. Get a good 9-volt battery out of a pack. Put it in the tool. And again, retest. If you're still not hearing the horn and seeing the light, you want to get the tool tagged, get it out of service, get it sent back to the manufacturer, whether it's us or whoever. For all of our tools, no matter how old they are, we'll repair them. So some tools in the field are still functioning at 30 years old, and we'll repair those. If something happens, if they're dropped, broken, we'll repair them. So real quick, for an analog tool, I'll give you a quick example of what you should expect. These tools, for our tools in particular, you'll either have a test position or a toggle switch. You want to flip to that setting, and you want to see a deflection of the needle or a peg of the needle. If you're seeing a weak deflection or no deflection at all, there's a chance the battery may be going dead or already dead. Same thing, you want to get a good known working battery in the tool. If you're still not seeing any deflection or the deflection's weak, you probably want to get the tool tagged, get it out of service, get it sent back to the manufacturer again, whether it's us or whoever. for a digital tool, like I've said, our tools in particular have 9-volt batteries. So same thing, they'll either have a test position or you'll flip it and hold to the far setting. So I'll do that real quick. Let's see. Try to get out of the sun here. So it's reading 7.3 volts on the battery test. For the digital tools, we recommend not using them anything under 7 volts. The tools will still work. We just recommend keeping a good battery in these tools to make them the most effective. They'll give you the best information when they've got a battery above 7 volts or greater. So keep that in mind. Like I said, for any manufacturer's tools, the battery test is not a true tool test. And again, we'll go in more depth of what would be considered a true tool test shortly. But I want to talk about tool functionality. And again, this is across the board for our tools and any other manufacturers. And it goes for a wireless voltage indicator, voltage detector, or a corded tool. They work the same. The only difference is the corded tools have a direct relation to ground. So what a wireless tool in particular, what it's more prone to, is how it works is the tool is going to make direct contact. The conductive components inside the tool are going to couple with the capacitance you're working with, and it's going to look at the current in relation to ground through the air and give you a voltage indication. So whether that voltage indication is the horn and light, the analog meter, or a digital scale, it's gonna have to look at that wirelessly through the air, the current flow, and then it's going to give you the voltage detection or voltage indication. So if you think about that, since this tool's having to couple to the ground wirelessly, what we can do as a manufacturer is on our tools, we can put a scale on the back of the tool to tell how far from the ground you're working. That's going to make the tool more accurate in each different scenario. We've got URD, OH, and OHT. URDs for underground residential distribution. You're telling the tool you're pretty close to the ground plane. Maybe you're working in underground, so say an underground type scenario, or maybe you're nearby some grounded components. So maybe it's an overhead line, but you've got metal structures nearby. You can use the tool in URD. It's going to be most accurate in that scenario when there's ground planes nearby the tool. OH for overhead. Maybe an overhead scenario where you're about 15 feet up to about 35 feet above the ground. And then OHT, the tool's going to be most sensitive here because you're telling the tool you're really far from the ground. OHT stands for overhead transmission. So about 40 feet and above, you're going to use the tool in OHT. It's going to make the tool super sensitive. Again, because this tool has to couple to the ground wirelessly, you're going to be telling the tool you're very far from the ground plane. So, some quick info about our tools. What we do in the probe here is we put resistors in here and we encapsulate them in epoxy. The resistors first are to protect those conductive components that make the tools work, as well as you being the user. So what we also do is we encapsulate those resistors in the epoxy. That epoxy keeps out any type of outside atmosphere, such as dirt, water, or grime. Keeping out dirt, water, or grime, what it does is it limits the potential of a track to those conductive components internally. What you can do to limit the risk of an external track is you want to keep the tools clean. If the tools aren't being kept clean and you do happen to start using these tools improperly, you can start having the possibility for an external arc flash. And we'll go over some tool use and show proper use. That way, first you're using the tool safely, and then also you keeping the tools clean. That'll limit that risk for an external flash. Another thing we got here is a line limit mark. That was a recommendation by ASTM to add that line limit mark. What it is it's a line, kind of a guide point of where you don't want to bypass on the probe with either a nearby potential or a ground plane. So for the same reason, since the components in here that make this tool work, and any other manufacturer's tools, are conductive, if you start bypassing that probe and coming in close proximity while you're making contact here on the probe tip, what you could cause is, again, an external flash. And 9 times out of 10 for our tools, it's not going to hurt the tool, but obviously you're using the tool improperly, unsafe. So you want to try to limit that type of work approach. Another thing I want to talk about is that using accessories on the probe tip of the tool. When you're using the tools on a secondary voltage, you can make direct contact with the probe tip, but we still recommend using an adapter. So anytime you're working primary voltage especially, you want to use adapters on the end of the probe tip. What the adapters will do, whether it's a straight probe or a hook probe or a bushing adapter, what it'll do is it'll help better your depth perception for that same reason. Is if you've got an adapter on here, it's going to limit your risk of bypassing first the resistors in the probe, and then also keeping safe work practices as far as not bypassing this probe with a ground plane again or a potential.
So keep in mind, folks, that we are doing the Lineman Safety National Webinar starting February the 7th. Well, we actually did one November 001 episode. 002 episode will be this February the 17th. And we are going to have the best speakers, the best safety trainers, consultants in the country that are going to be guest speakers, and they're going to have a different subject matter each time. And we are booked up throughout this entire year. We're going to have like I said earlier, Danny Rains is coming for 002. We're going to have Lido Wilkins coming in April. And we're going to have Caleb Thompson and Brady Hansen in June. And then we're going to have Jim Vaughn in August and Bill Martin in October. So we've got a whole line of speakers. Once you're in the system, you'll receive notifications from us, our reps. And then that way, you guys can pick and choose what you want, and again, they'll all be archived. Similar to today, you guys can ask for the recording and you can receive it. So they'll be available. So what's interesting is yesterday we were talking about a safety culture, just redefining this throughout the industry. And that's what this is about. We want to work together with professionals and safety folks and redefine this with a new passion. And so Bill Martin said, hey, we're going to call it a culture of safety. All right, not a safety culture. We're going to call it a culture of safety. So that's what we're going to be working with. So you guys can help us spread the word and help our folks to come home. So what we're going to talk about now is, typically in the industry, it's normal process that a voltage indicator, phasing tool, wireless, corded, these tools that are trusted lives are being trusted by the tools, and they're handed to the folks. They're handed in a nice case or a bag, and they say, here, go ahead, here's your new tool. Regardless of manufacturer, the safety is going to be going across the board. You must remember this, that the safety we're going to talk about is irregardless of manufacturer, color, anything, corded, wireless, it's all going to be the same safety, non-bias, all right? Since we make these tools, guess what? We're going to use these tools to present the safety. But this safety is super important. So what they do, here's the equation of how these tools work and everybody else's tools work, is they make contact with the conductor, whether the conductor is energized or de-energized. So that right there is going to be your X. The conductor is X. Plus Y. Y is going to be how the tool functions, the functionality of the tool. That's the Y. So the tools make contact with X, the conductor, couples with that capacitance, and the tool looks at that capacitance, that current, in relation to the ground plane. That's how these tools work. Wireless, it looks at that current in relation to the ground plane wirelessly. If it's corded, then the tool looks at that current in relation to the ground plane via a cord. Basically, they work exactly the same. cord or wireless. It's still looking at the current in relation to the ground plane, and the tool itself is going to give a voltage indication. That's what they're designed to do, give a voltage indication. Wireless or corded, that's how they all work. So this is simple now. These tools, in order to work, they have to become energized. Remember, Ryan talked about the components inside the housings. The components are conductive. So in order for the tool to work, the components have to be energized. The tools are not isolated. The tools are not insulated. They're actually energized. And a lot of linemen don't realize that. They've been using these tools for decades, and they never came to the conclusion or the understanding that the tools, in order to work, are energized. Well, they are. And we're going to prove it, and we're going to show a lot of safety today regarding that fact. You want to turn off on park? Good? Okay. So, X plus Y. The conductor plus tool functionality, regardless of manufacturer, equals. The equals over here is going to be safety and information gathered. Safety and information gathered. That's how they work. So let's talk about that, the safety. Remember, the battery test is not a tool functionality test. You always want to use a live known voltage source, which the 9-volt battery is not a high voltage source at all. Okay, so just always remember that. Also, when using these devices, many of the guys for decades are using these tools from time to time by what we call tool gloving. So they take the hot stick adapter, which is on the quick change, and they're actually putting the tool in their gloved hands. And they believe, because they've been doing this for a long time, no one's ever trained them otherwise, that this is a safe procedure. And this is completely unsafe. Because what is happening by tool gloving is the line worker is entering into the equation of how the tool works. So then the tool becomes X plus Y plus the line worker, and you never get equal safety. And you never get proper information gathered, because the tools are not designed to be used in this procedure at all. Never were, never have been in the history of mankind. Okay, that's a long time. All right, so that's tool gloving. We don't want to do that, or we don't want to have a nickname called short stick, and this is short sticking right here. So we don't want to be a short sticker. What happens is we are also entering the equation of how the tool functions. X plus Y plus me does not equal ever safety and proper information gathered. Never does. Because the tool makes contact, the tool couples with that capacitance, looks at the current in relation to the ground plane. When we short stick or a tool glove, we're telling the tool, literally, by using it thusly, we're telling the tool that I am the ground plane that I want the tool to look at. Think about it. Look how close that ground plane is right here, the potential ground. We're all potential grounds all day long. All right, and the line worker, they need to know this, that this is truth, this is reality. All of these guys, they work these bad habits, and they've been doing it for decades. And we hear these stories about guys getting hurt. They just didn't know. No one ever trained them. The basic concepts of the tool functionality, and they are getting hurt. When we enter the equation of how the tool functions, what happens is we're trusting a good friend, our gloves, and we're kicking our best friend to the curb. Our best friend is going to be that air dielectric right here between me and that tool. We recommend 31 inches or more. A lot of utilities go with 36. That's great. Let's go with 36. That's even safer. But that keeps your air dielectric. That is your best friend. Sometimes a good friend, your gloves, could let you down, and we're going to go over that as far as how good friends have let people down in the past. And so they trust these good friends, and they kick the best friend they possibly could have, that air dielectric, to the curb. Your TPGs, they are to be considered a best friend as well. So you got to take care of them. But also your air dielectric is another best friend. Super important, okay? We were doing some training in California several years ago with a utility. And afterwards, a lineman, about 25 years in the business, came up to me. And he actually told me he appreciated the training. And he told me that he was used to going capacitive test points with the tool in his gloved hand. And one day, out of the blue, he made the decision to actually not use his gloves. And he placed the tool, he placed that hot stick adapter in his hands, went to the capacitive test point. One time in his life. One time. It's all it takes is that one time where you're not thinking. That one time where you really, truly don't understand what you're doing, even though you think you know what you're doing. Okay? And when he went to that capacitive test point, you know these tools are energized. What do you think happened? Yeah, he got hit with that potential. About 10% of the nominal voltage. He got hit with that. Maybe a couple hundred volts. All right? He'll never do that again. But right here, this is one mistake. This is a bad habit. Right here. And one bad habit, many times, can lead to another bad habit. Right here. Boom. And that's how these guys get hurt. They don't realize it's a bad habit. They've been doing it for decades. Maybe they retire and they never knew any better and they're fine. But what happens is all these guys are so influential. You all have so much purpose. You're super important to the folks around you. And by doing out in the field these bad habits, by performing these bad habits, what we're doing is we're training apprentices. We're training other guys that are journeyman linemen all around us. We're training the same bad habits to them. So what happens is maybe they leave. They go to another utility. They go to a contractor. They go somewhere else. And they take that same bad habit that you were training them, teaching them for all these years with them. And then they're training these guys to do the same thing. And no one's talking about nothing. They're just going to work and they're all excited about that paycheck, that big paycheck. Well, guess what happens? The guy gets hurt, gets killed. He ain't collecting that big paycheck. So what is it worth? We got to discuss this with one another. We got to, we say we're our brothers and we're our sisters' keeper, but are you really? We need to think about things and we need to watch out for one another. We need to have these discussions out in the field. We see something going on that's improper. That's not a work method at all. It's a bad habit. We need to discuss it. All right? So when we're training the folks, typically we go to OSHA, that 1910.269 lowercase n, and we go to number 5. Number 5 talks about is TPGs, your temporary protective grounds, installing them. Well, we're not going to install them until after we perform a test. And so typically it's trained open test ground. That's typical. But how we like to train it and how we prefer, and this is what's spreading throughout the industry, and this actually needs to be changed in the regulations. This procedure needs to be changed. Maybe you guys could help us, all right? Help each other. We got to change these. Is instead of open test ground, what we're going to do, and every single time at every address, every day, is we're going to test on a live known voltage source. If we don't have a live known voltage source, we're on storm restoration, all right? If we're on an outage, then we're going to carry our 3 kV power supply around in our kit. And that's our live known voltage source, because a battery test does not test the tool functionality at all. So we're going to test before we open the switch, okay? If you have elbows that do not have capacitive test points on them, which many utilities do, they can have a mixture. Some have them, some don't. We're changing them out to where they all have them, but we still have a few that don't have capacitive test points, or maybe vice versa. Then you can get a meter, which we make, that has a P setting, proximity. So we can go to the base of your elbows and we can pick up that capacitance at the semicon material at the base of your elbows if there's no capacitive test point, all right? So you can put it in the P setting and sniff that capacitance, no problem. It'll do that. But typically what we're gonna do is we're gonna prefer a direct contact, URD, like Ryan was saying, because you're close to the ground plane, Our tools are the only tools created and built right over here in our factory in South Carolina from scratch, every day, all day. No, not the weekends, okay? That discriminate between close to the ground plane, like Ryan was saying, and far from the ground plane. Overhead, overhead transmission. Overhead transmission, obviously, you're further from the ground plane. Pretty simple, but they're gonna be more accurate for you. So what we're gonna do is we wanna use a direct contact tool. Always use the proper accessory. If you do not use the proper accessory on your cone tip, that's called a shortcut, and we don't take shortcuts. You'll always use the proper accessory. So we're gonna go to these hot bushings right here. All right, and we're gonna call this right here, we're gonna call this an overhead line. Pretty low to the ground, but it's an overhead line. You got to duck when you walk to it. And we're going to put our tool in URD. We're going to make direct contact. If we're on underbuild, it's important that you always use direct contact tools, because these non-contact tools that some utilities, some contractors are using, they create a guessing in a line worker's mind. They're presumptuous. In other words, we're not going to be sure if there's an absence of our nominal voltage. We'll probably have a pretty good idea, but the regs, that's what the regs say. But we're going to train it. We're going to look for a lack of not only nominal, but we're going to look for a lack of induction and backfeed on top of our system voltage. And you want tools, say in an underbuild substation, you want tools that are accurate enough and reliable enough to verify an absence of all three. Every time, every job site, every time, all day long. So that's what we're gonna do. We're gonna make direct contact, so we're gonna test before we open the switch, or we're gonna test our tool on a live known voltage source. If we're in an outage on a 3 kV power supply, it's fine. So we're gonna test. We got this overhead line, and you guys see those numbers? Okay, so we got direct contact. So we know for a fact that this tool is working. It's reading a little high. It's a little moisty out today, and the meter head is close to the ground plane and close to the source. So we know how the tools work. So because it's close to the source, close to the ground plane, our voltage indication is going to be a little on the high side, and that's fine. But we know the tool is working. All right, on a live known voltage source. Then what we're going to do is we're going to simply open the switch. So the tool, we open the switch, and the tool is letting us know that we have an absence of our nominal voltage, and we have an absence of any backfeed, and we have an absence of induction, all three. And this should be written in the regs, but it definitely needs to be trained. So now what we're going to do is we're going to test the tester. We want to make sure the tester was working properly on that live known voltage source. So we have a handheld power supply right here, and we're going to simply test the tester. Okay? Test the tester. The tester is definitely working without a doubt. We're not presumptuous, we're not guessing, direct contact, and we know for a fact that we're safe to put on our best friend, our TPGs. All right, so that's what we're doing. We're gonna test, open, test the tester, ground. 5 steps every time. One of the biggest reasons why we do test first is not just because we're testing our tool on a live known voltage source, but we're also verifying that our head's in the game. If I'm working with you or you're working with me in the field, you deserve to know that my head's in the game. It's called mutual accountability. We're lacking a lot of mutual accountability in this industry, and this needs to be taught all the time, every day, all day long, and we got to live it. A culture of safety, and that's mutual accountability. We got to spread this word. I'm mutual accountable to you. You're mutual accountable to me. Every job site, all day long. Period. So we're going to test with the tester, whether we're phasing, whether we're verifying voltages, or whatever we're going to do. We're going to test with the tester to verify our heads in the game. That's the number 2 reason. Mutual accountability. We've got the cones out. We see all the hazards, all the slips, all the risks. We see everything. We got the cones. We did our tailboard. We did our job briefing, whatever you want to call it. We know where the gators are because we might be close to, some swampland here in the lower part of South Carolina, possibly. And we know where the water moccasins are. But do you know that my head's in the game? Do I know your head's in the game? So we're going to test first. There is so much bull crap out there, guys. Politics and on the television and all this crap that they're saying. And that's what it is. It's just bull crap. And what they do is they tell you the bull crap. Why do they tell you the bull crap? Because they want you to listen to it, believe it, and have it in your head. If the bull crap's in your head, the chances of you not being mutual accountable and being safe and watching out for one another is much greater. Much, much greater. So just turn that stuff off, unplug all that crap, and start plugging in to a culture of safety in each other. Watch each other. That's so important. So we're going to test. Open, test the tester, ground every time. Okay? All right. So what we're going to do is we're going to re-energize this overhead line. You get set, right? And this mutual accountability, there's a couple incidences that have taken place. And thank you, sir. Perfect. And one thing we do, because we've traveled around and doing the safety and getting involved with all these associations, we're involved with about 10 associations now, electric cooperatives, municipality associations in different states, and we're teaming up with these folks. It's hard to say these words when it's cold out here. It's like 30 degrees this morning, but your lips stop moving. They're like hard rocks flapping in the wind. But anyways, what we're going to do is we're teaming up. We're teaming up with you folks, just the same. We got to just team up. And we hear these stories. So this one situation that happened up in Michigan. 2 guys were working. They were changing out a broke pole, and they were working. The system was hot, and they knew the system was hot. And they've been doing this for years. One guy was a 20-year journeyman lineman. Been doing it for a long time. Knew his crap. Knew his stuff. Like the back of his hand. Easy peasy. They were out in the field, and what happened was his partner was lifting the pole out of the trailer, and his partner was in the truck pulling out some gear. Well, the boom hit the energized line, and his partner, 20-year journeyman lineman that was in the truck pulling out some gear, became a ground for that potential. And our bodies that we're borrowing for a short time, our bodies, they come right here. They come from this right here, dirt and water. They come from the ground. And if we give it an opportunity to go home, that stuff wants to go home so bad, man. Make a circuit, right? Go back home, complete that circuit. And it wants to go home. And if you give it that opportunity to go home, it's not going to ask permission. It just will. And in an instant, his wife lost her husband, the kids lost their dad. All right? So his partner that was working the boom had no mutual accountability. To the gentleman that was in the truck, 20-year journeyman lineman, no mutual accountability. To his buddy in the truck. His buddy in the truck had no mutual accountability to his buddy working the boom. You see how that works? So both of them, that's one word, both of them didn't have mutual accountability. All right? So we need to have mutual accountability one to another. Simple. If I'm in the truck, I know where you're at with that boom. Period. Before I get in that truck. And before I go to the truck, you're going to know where I'm at while you're working the boom. So we're going to work together. How do you think the gentleman that was working the boom, how do you think he feels today? That's not fair. We need to look out for each other. He's carrying that weight on his shoulders to this day. How do you think that feels? That's not fun. All right. So what we're going to do is we're going to have mutual accountability every day, all day. And from time to time, we're going to be working these tight spaces, maybe a substation. We're going to be working a tight bolt. And we know how these tools function. So what we're going to do is, to prevent any arc flash, and this is a call that we get, one of the top calls we get over the last 7 years since I've been with Bierer meters. One of the top calls we get is our tool had an arc flash, or your competitor's tool, we had an arc flash with the tool. And they send us pictures, we discuss it. And what happens is we see these pictures and we realize that these folks need some lineman safety and tool training, because they didn't realize that the meter, whether it's wireless or corded, the meter's energized. So remember what Ryan was talking to you all about was that line limit. You're not to bypass that line limit with an energized source nor another a potential ground plane. Well, that's the same goes all the way around the tool. So if you're working a tight bolt and that cabinet or a tight cut cabinet is right here, what happens if I inadvertently move my hot stick and now the meter head's touching or in very close proximity? I'll have an arc flash. And this is what's happening out in the field. Maybe I'm working a substation. I'm checking out a conductor at a substation and I've got a hot bus right next to the meter head, corded, wireless, whatever. And I got a hot bus right next to the meter head. Well, I'm going to have a crossover, flashover right there too. So, and this happens, we get these phone calls. So to prevent that, what we're going to simply do is we're going to put on a 0-ohm extension. And these are great to have in your kit. You're not going to use them all the time, but when you do need them, they're there and available. And they simply give you that extra distance from that potential ground, that extra distance from the potential itself. So without the 0-ohm extension, I'm going to visually inspect the work area prior to using the voltage indicator or phasing equipment. And I see that the meter head is going to be close to that ground or other potential. So I'm not going to use it because I know how these tools function, because I've been trained lineman safety and tool training. All right, that's what I've been trained. So what I'm going to do is I'm going to put a 0-ohm extension. So here's before and here's after. You guys see how that works? So you're not going to have an arc flash. So let's go back to that overhead line and see the results. Y'all have any questions thus far? Y'all good? Huh? Y'all here? Can you hear us? Okay. Everybody hear us? Good? All right.
Yeah, we can hear you, Brent.
Okay, thank you. Any questions? Anybody have any questions? Good? Okay. So what we're going to do is we have the 0-ohm extension on and we're going to use it with our tool, because we have a situation where we have a potential arc flash. And you will see that number, it was reading higher than that prior to than what it reads now. Well, the reasoning behind that is because we have the 0-ohm extension on, and the meter head, two physical things have taken place that are truth. They're truth. And one of those physical things that have taken place is the meter head itself. Here's the meter head. The meter head itself is further now from the ground plane. The meter head itself now is further from the source or another potential. So the tool is going to be more accurate, because you know how these tools work. They look at the current, they give you a voltage indication in relation to the ground plane. Well, if you have a source near the source you're making contact with, it's going to be influencing your reading. If you have a ground plane too close, it's going to be influencing your reading. It's not going to be as accurate if it's very close to the meter head. So that's why a lot of times when you're using the tools in a substation, we actually tell the guys if they're close to a ground plane, because the substations are loaded with grounds everywhere, sources everywhere, is to go ahead and put the tool in URD. And a lot of times you'll get a better reading, more accurate reading because of that, because you know how the tools work. So this is important, all right? So what we're going to do now is we're going to talk about a situation. We were doing some training in Tennessee, and we were doing test, open, test the tester, ground on one of these pad mounts of this trailer. And the guys came to me and they said, hey, we had an incident. And in this incident, we had an arc flash. So one of the linemen, they were working the stick. They were working the elbows on the cabinet. He was back on a stick working the elbows, and they were working hot, and they knew it was hot. And they were working, but you see, I have my air dielectric. All right, so he's safe, man. And the other guy noticed the cabinet was loose from its foundation. So just always remember, you need a good foundation, solid foundation in your lives. That's important, all right? Cabinet was loose from its foundation. His buddy, working together as a team, he walked over to that cabinet and he puts his hand, boom, he puts his hand, gloved hand, on that cabinet. So what he did is he kicked, when he put his gloved hand on that cabinet, he kicked that best friend, that air dielectric, to the curb, and he trusted his good friend, gloves, all right? And he got arc flash. He coupled with that capacitance, he crossed the red line, coupled with that capacitance just enough, that primary power, just enough to where it coupled with him, the ground, it went right across his glove to ground, all right? And he got burned up, spent some time in the hospital, he's fine. But an arc flash will mess with your mind forever. It's a scar that you experience, and it just messes with your mind. And it gets kind of spooky, all right? Because there's red lines out there. If I take my gloves off and I touch this 120/208 panel right here, barehanded, then that's crossing a red line. And the linemen, when they're out in the field and they're working hot, there's red lines all over the place. That's why MAD has been established and written. But depending on environmental conditions, depending on body placement, proper body placement, improper body position, depending on all these factors, these red lines can adjust somewhat. They can move somewhat. Well, it moved enough to when he put his his gloved hand on that cabinet, he got arc flashed. All right, kicked his air dielectric, his best friend, to the curb. And the incident report was quite handy, quite telling. The incident report, which is amazing, because this stuff, we're thinking it's a theory. It's not. This is reality, and we need to teach this as reality. And it's not a theory. But in the incident report, they wrote and they said the reason why he got arc flash because of rat piss on the cables. Okay. Well, that's escape rat, I told those guys, and that's not what happened at all. Had nothing to do with it. So anyways, check out those numbers on that meter. Okay? And you'll see, what are they doing? Are those numbers going up? Yep, they're going up. So what's happening is I'm getting close to that current, and I'm coupling with that current, and you can see that those numbers adjust. They go up higher because I'm encroaching on that current flow that's truly flowing. It really is flowing, measurably so. And what happens is if I'm working these tools and I'm working them with a gloved hand, I'm tool gloving. All right, that's a horrible nickname to have, by the way, if you're a lineman. Tool glover. If I'm tool gloving this tool, I'm coupling with the capacitance of how this tool works. And I'm telling the tool that, tool, you're this big plus me big. X plus Y plus me never equals safety. Never, and it never equals proper information gathered. And we just proved that information was skewed, incorrect. So it's important that to understand why the little birds land on the lines, but not the big birds, okay? And you don't want to be a bigger bird. You're doing this with your tool, you become a big bird on the line, and it gets uncomfortable from time to time, and you can feel that jolt, that shock, all right? It's a shocking experience, you might say, huh? So anyways, you don't want to become a bigger bird with your tool. Stay away from that tool. Keep your best friend, air dielectric. All right? Okay, Ryan. Got your gloves?
No, where'd they go?
Are they in the truck?
No.
They're in the truck.
Yeah, never.
Ryan, when we make this recording available, Parker's going to edit that part out, okay? So you won't see Ryan where he does it. He's young, and he doesn't even remember where his gloves are, okay? What kind of excuse do we have when we get older? Okay.
So I'm going to use the PD25. It's our corded voltmeter / phasing tool. It's accurate, just like a little fluke meter. Starts working at 1 volt all the way up to 25 kV. I'm going to put it in the 2 kV setting, and I'm going to take some measurements across Brent's body when he's using the tool properly, working on the end of his stick versus when he starts getting close proximity to the tool via short sticking or tool gloving. As I go along, we're trying to remember these numbers. So first I'll take a reading across his foot. You see about 7 volts. Go to his body. We see about 13 volts. And then we'll go to his front glove, about 19, 20 volts. So not a whole lot there. Then he'll short stick. And let's see the difference here immediately. Go to his foot. Now we're seeing about 18 volts, 19 volts. Go to his body. See about 26 volts. Then we'll go to his front glove. Now we see right at 50 volts, 47, 48 volts. So now he's going to short stick, or tool glove. And you see as he starts getting closer proximity to this tool, he's got more charge built up on his body. Now across his foot, you see about 67 volts. Now we're seeing a little over 100 volts, 105 volts. And then we'll go to his glove. And now we see 191, 192 volts. So.
Okay, so that's reality. That's not made up. That's reality. When we're working unsafe, dangerously actually, when we're short sticking, that is not a proper work method at all. That's just disrespect for safety. When we're short sticking, when we're tool gloving, same thing. There is nothing safe about it. You're entering into the equation X plus Y, and you never get safety. Never has been, never will be safety. So we got to keep our air dielectric. So about a year ago we were doing training, and we've been doing this throughout this whole, whatever you want to call it. I got my names for it. And traveling and going across the United States. And you know what? We're healthy, we're doing great. Hugging guys, holding each other, keeping each other safe, watching out for each other, and we're just fine, okay? Take care of yourself, you'll be fine just the same. Anyways, we were doing training about a year ago in Georgia, and some safety higher up said, hey, that's pretty amazing. And we've got some overshoes here, super dielectric. They're beautiful, huh? That's a fancy word. Super dielectric overshoes. And they said, we bet you that if you wear these overshoes, and they were brand new a year ago in a bag, shiny bag, and they said, we bet you if you wear these overshoes that those numbers don't go up. All right, so I said, okay, I'll tell you what, we'll make a deal. And we did, we made a deal. If those numbers go up, and even similarly without them, then I get your boots. And I get to use your boots from now on for the training. Is that a deal? And they made a deal with me, as you can see. So let's put these on real quick.
timing you.
I know. It's hard to move. I got so many layers on. Instead of a redneck, I feel like a stiff neck. Okay. We'll just go straight to...
Yeah. So, you guys remember those numbers from the last test. I think, what were we seeing on his foot last time?
Right there.
I think I was right, about 60 volts.
Yep.
On his back, I think we're seeing 120 volts. So now we see about 100 volts.
Mm-hmm.
And on his glove, I think it was right around 200. So 156, right at 160 volts.
160 volts?
Yep.
Okay, so the numbers are similar. So what happens is I've got a super dielectric on my hands. We got some super dielectric on the feet. So what I've done is I've become a capacitor. And we've been in the field doing this. And you could actually see the capacitance. You could see the charging, those numbers build up on my body over a period of a short time. And they actually build up on my body. It's pretty freaky. And we've gotten up to 1,000 volts on my back when we were in Mississippi once doing training. And little droplets were floating through the air. And it was a real moist, remember the environmental conditions. So everything changes and those red lines come out. And it was actually reading about 1,000 volts. And that little probe tip there, it bit me. So you had to hold it on tight to the back to keep it from arcing, getting that bite. So it can get pretty bad sometimes. All right? Anybody have any questions thus far? We good? So another incident took place a few years ago. Mutual accountability here. All right. So another incident took place, and one lineman was in the bucket truck going up to some energized conductors, some long source. Anyways, he was going up to some energized conductors. His partner was in the truck, not watching him. His partner was in the truck, not watching him. What happened is his bucket got hung up on the communication line, that lower big old cable at the bottom. The communication cable got hung up while his buddy was in the truck. Okay? There was no mutual accountability from the guy in the bucket truck to his buddy in the truck, nor his buddy in the truck to him in the bucket. Both of them. There was no mutual accountability. His bucket got hung up, and so he's working the hydraulics, building up some pressure, building up some steam, and that bucket came loose. The bucket came loose and shot up just high enough to where his arm came in contact with the energized conductor just barely above him, and he lost his arm. So again, guys, gals, we need mutual accountability. We need to watch each other. There's no reason to be in the truck when your buddy's in the bucket. You got to watch him. And then there's no reason for the guy in the bucket to be in the bucket if he's not making sure his buddy's watching him. So it goes both ways. Mutual accountability. Okay? Okay, Ryan?
So now, we'll show you using a corded tool, how you can use a corded tool to actually phase off capacitive test points. Since this tool is accurate, like I said, it's going to start working at 1 volt. What we can do is we can take some voltage readings and get a good indication of whether or not we're in phase or out of phase. So first we'll come over here, and with this tool, just like the wireless tools, we're going to test first. So we're going to go phase to ground. The reason we're going to go phase to ground first is to give the tool a tool test. So we're seeing 350 volts. We're going to want to remember that number, because what you're going to do when you're phasing off test points is you're going to see the difference. When you're in phase, you're going to see the difference of the two tests. The reason there's going to be a difference is because each elbow is going to have a different resistance value. It's going to cure different. So here we see 350 volts. We're going to go to the other elbow now, and we see about 275 volts. So we say about 75 volts difference?
Yeah, about that.
So if we see about 75 volts difference, since that's the difference in the two values, we'll be in phase. We won't see a zero, we'll see the difference of the two values. So we'll do that real quick. Again, we're expecting to see about 75 volts, and we see about 70 volts. So if we're out of phase, what you would see is that 1.72 multiplier, and this of course is nowhere near that. So
yeah, stay there, right?
We see our difference here.
I'll go to
we'll give you an example of what you would see if you were out of phase. So Brent's going to go over here to this other elbow. Out of phase, make contact with the test point. And there we see about 588 volts. Go to the lower one there. There you go. So we see about 500 volts. So we know for sure we're not in phase here. So pretty quick, pretty simple. It's a lot safer than having to work through a feed-through elbow. If you can help it, you just go to the capacitive test points. So real quick, we'll show the voltage capabilities of this tool.
Go ahead, right?
Like I said, it starts working at 1 volt, so we use it here on this 12208 panel. Phase to ground, we see about 121 volts. We'll go phase to phase, in phase, we see 0 volts, so we're for sure in phase. It looks like this cabinet's labeled correctly. And then phase to phase, out of phase, we see 214 volts. So now we'll show you using the tool on the primary power, what you should expect.
You guys hear those birds in the background from time to time? We got a lot of birds here. I was doing some training in North Dakota. Believe it or not, North Dakota. Yeah, that's not making it up. Last week. And it's so freaking cold in North Dakota. I didn't see any birds. None. Because the birds are smart in North Dakota, smarter than the people. When it gets cold, they see where that sun is, and what they do is they actually fly. They move. And they go where the sun is. North Dakota folks, they don't understand that yet. So, anyways. Okay, Ryan.
Yep.
Go over the procedures and why.
Alright, so again, working primary voltage with a corded tool, you're going to go phase to ground first. For that same reason, you're going to verify the tool's working, and you're going to let yourself know you need to get your head in the game. So, make contact. We get a 1 off the bat. We're getting a 1. The tool's just telling us we're using it in the wrong setting. So all of our tools, if you use them in the wrong setting, it's not going to hurt the tool. It's just going to give you that funky reading. So I'll flip it to the 25 kV setting. Maybe. Maybe if I have the right size glove on. That's all it.
Oh, you got it? Okay.
Yeah. So we'll go phase to ground again. And we get 20.9 kV. So you see now, versus using the wireless tools earlier, you see how good those tools were working when you're using the 0 ohm extension and getting it out away from the cabinet some. So
Okay.
now we'll go stick the second probe in.
Okay.
See if we're in phase. What are you gonna say?
And we know phase to ground, so we verify 3 things. We verify that we're energized. Obviously, before we phase, we verify the tool is functioning on a light-on voltage source, and we also verified that we have mutual accountability. New address. We've got the middle pad mount address here. All right, the middle pad mount address, which was different from the left pad mount address. Same day. But we still got to establish at this job site, different job site, same day, that Ryan and I, we have mutual accountability one to another. 3 reasons why we're doing this. Okay, go ahead, Ryan.
So we see close to 0, we get a 0.3, so the 0.3, it's just going to be the little bit of bleed that's in that cable. So it's laying on the wet grass, so not quite 0. But anytime you're phasing with a corded tool, or maybe you're testing cable, high potting, what you're going to want to do is you're always going to want to take the second probe to ground first when you're done performing the test. So the reason for that is, 1, if you're high potting cable, you want to de-energize that charge you put on the cable to test it. Or 2, if you're just phasing, you want to de-energize any capacitance that's built up between the 2 probes in the cord and between the 2 meter housings themselves. So as I take the meter probe off, you'll see those numbers dissipate, discharge to ground. And it takes a second just because of the resistors in the probe. There's nothing wrong with the tool, it just takes a second to bleed off that charge. A good rule of thumb, if you're using a corded tool to high pot, is however long it takes to charge that tool up, that's how long you need to take the tool to ground to dissipate any charge you put on it during the test.
Okay, everybody, about wrapping it up here. I hope you all enjoy. We'll take a few questions if you have them, but also just real quick, there was a situation a couple years ago. We get a phone call from a cooperative in Texas, a large cooperative in Texas, beautiful location. I like training linemen in Texas. They like to eat a lot, and they always take our extra large and XXX and XXX t-shirts. So it's a little more costly to go to Texas, but anyways, they're good folks. But we got a call a few years ago, and this call came from the higher ups in this company and the tool people, and they said basically they didn't trust our tools no more because they had an arc flash. So we were like, well, anyways, we kind of know what's getting ready to happen then, because we get these calls, and we just know what's going on. And we said, well, send us the pictures. They sent us the pictures, and what it was is they were using a corded meter. They were using a corded tool right here, and they made contact with the conductor in the substation, and they didn't properly visually inspect their work area prior to using the meter, and they didn't understand how the meters worked at all when they used the meter at all. They were just handed the tool. So anyways, when they made contact with the conductor X, the tool became energized, but guess what? There was another X right here at the meter head. Another X, another hot conductor. So obviously you already know what happened because you know how these tools work. And that's exactly what they happened. They had an arc flash. And the tool exploded here at the interconnect cable here. The potential ran down that cable to the secondary probe and blew up there. And the cable in between was fried. All in pieces, blackened, charbroiled basically. It's like a South Carolina barbecue, okay? No mustard sauce, but it's just a barbecue. And anyways, the linemen, what happened was, this incident, they dropped their tools, went running screaming like girls. Because I told those folks that you guys need some lineman safety and tool training as soon as possible. And I got there, and those 2 guys gave me the story, which I already knew what the story was going to be, and it was exactly that story. So what happened is they were working. They made one mistake. They had a hot bus next to the meter head, but their work methods they trained is that they're to be 36 inches away from their meter and 36 inches away from their cord at all times when they're using it. And this needs to be written, this needs to be discussed, needs to be trained always. You cannot have your cord a little extra laying next to your feet in the bucket truck. You've got to make sure you're 36 inches away from your cord when you're using it at all times. Well, they were. And the good thing that they were, because they were both able to tell me the story of what happened. If this cord was close to them, maybe rub it on their thigh, all right? When this incident took place, one or maybe both of those guys wouldn't have been able to tell me the story. And that's what happens. Real quick, let's talk about proper body position. Here you go, Ryan. Go ahead and take that and set it there wherever you want. So proper body position. This is crucial, and this happens often because they don't understand how these tools work and how these tools function. So you got to have proper body position all the time when using tools. So we've got a corner pole right here, as you can see plainly. This is a corner pole, and it's leaning a little bit because it's from Kansas. There are some areas in Kansas that have a lot of poles leaning. So this is Kansas out in the country, okay? And I get a call from the lead lineman, true story, in Illinois. Big cooperative up there. And he calls me and says, hey, your analog tools are no good, they're broken. Right here, they're broken, they're not giving accurate readings. I'm on 7200, I'm getting 13,000 volts. And I already know what's going on. So I tell these guys that you guys need some lineman safety and tool training right away. I'm not going to argue with this guy because you can't win arguments with linemen, lead linemen especially. So I just fly out there, do some indoor classroom training, kind of what we're seeing today. We go back out in the field. He gets up in the bucket truck, same scenario, same broke tool, and he makes contact, and he's getting 7,400 volts on 7,200 with an analog meter. That's pretty accurate. So when he called me when the tool was broken, he's at a corner pole, right here, corner pole. He had his back to that potential. And when you're working with the potential, you're working with these conductors hot. These conductors, that potential needs to be considered an enemy. So if that's going to be considered an enemy, why are you going to put your back to that enemy? Why? That's improper work method right there. That's not proper body position. It's improper body position. So, and then he's short sticking. He's got his gloves on and he's short sticking. So he's getting 13,000 volts. So I know when he's saying he's getting 13,000 volts on 7,200, that he's a living, breathing, wireless phasing meter. Think about it. He's phase to phase, out of phase. And that's what's happening. The capacitance behind him is coupling with his body, flowing across his body, across his gloves, through the tool, the opposite direction in relation to ground. He's making contact on that long source, and that potential is coupling with through the tool in relation to ground this way. So you add them up, and he's phase to phase, out of phase. The tool's working perfect. So after the class, that lead lineman gets in the bucket truck. Here's the corner pole. He's on this side of the stick. The tool has not changed positions. He has changed positions. That potential, which if he's working hot, that needs to be considered an enemy, it's in front of him. And look, I'm back on my stick, air dielectric. So his broke tool was miraculously healed. He's getting 7,400 volts. That's been several years ago. I haven't heard from him since. Also, another guy called me up and said, hey man, I'm using your horn and light, and your horn and light's broke. And I said, well, what's going on? He said, I got a switch open. I'm testing the conductor. The tool's telling me it's energized. Well, I said, well, test the battery. Battery's good. Test the tool on a live no voltage source. Tool's good. I said, the tool ain't broke. I said, the tool's fine. It's functioning perfectly. And I knew in my head what was going on. Again, he sends me a video. Switch is open. The tool's letting him know the conductor where the switch is open is energized. The reason why, same thing. He's at a corner pole. He's got his back to the corner pole, and he's short sticking. So the potential is flowing across his body, across his gloves, through the tool, this direction, to that conductor, charging it up. So it's a false positive, but it's not a false positive. He was positively performing a improper body position. So after the quick training on the phone, he changes his body position. He gets back on his stick. He makes contact. He simply changed his meter, his testing equipment is in the same position. He changed. He's got proper body position. And now he's getting a true negative. There's no induction, there's no backfeed, and there's an absence of nominal voltage. Okay? That's what's going on out there, guys. That's what's happening. Just need some basic safety and tool training. Any of you all have any questions today? At all? Okay. If you guys want a recording of this, you guys can ask for it and receive it. Everything is free. Hope you guys stay safe and be blessed. Bye.